here. I can make fun of me. Oh well. Okay, so what's the domain again? X or Y? Okay, so we're looking at the X values. Why do I need, I need an E on that. Why am I worried? Did I hit record? Oh, it's gone. It's gone. Okay, so why do I have to worry about X values? With fractions, why do I have to go back and revisit domain? What can't I have? Like, let's look at D. What can't, I can't have 0 in the denominator. So we're really worried about this value right here. What's going to make a 0 down there? So in letter D, what's going to make a 0 that I have to stay away from? Okay, so how do we express it? Do you remember we did it two ways? Negative infinity all the way to, and why did I use a parenthesis here? And then what did I do to get the other side of 2? Remember this guy? And then 2 to infinity, right. Okay, so that's my domain. Sometimes we could say all real numbers except 2. Okay, so we can write it both ways. Right now, that doesn't bother me. So if you look at letter D, like how would I know what values I couldn't have in E? It's not written quite like D, but could I change it? Oh, I could factor this. Let's see, both signs are negative. So I think a -2 and a -3 add to -5, but multiply to 6. So how many values can't I have down there? So let's kind of get a little bit more efficient on writing this. Let's go all reals except 2, and what's the other one? 3. And there are 2 values. How would I know that there were 2 values just by looking at this? What do you see in the, yeah. What would you do in F? Could you factor x squared minus 1? It's one of those special ones. Okay, what conveniently is going to happen here? Yeah, this whole unit, this whole factor cancels. Does that mean that I don't need to worry about -1? You still need to worry about it. So even though it went away, you have to think about what was I originally given. So all real numbers except 1 and -1. Questions on how I got that? So if I look back up here, do you remember how to find a domain given a graph? Which way do I look? Left and right or up and down? Okay, and if I put arrowheads on this, let's do that. I know I'm going from -infinity to infinity. Remember the parentheses, I can't include infinity, I never get there. Let's put an arrowhead on this. Okay, so where does this domain start? Bracket or parenthesis? Yep, good. -3 to infinity. And what about letter C? What is the graph of letter C? Is there any exceptions in a parabola, or can I put any number in there I want? Any number, yeah, because it doesn't have anything weird going on. So those polynomials that you just got done graphing, you can pretty much put any number into a quartic, a cubic, a quadratic, a line. Yeah. Oh, how would I write it? Any number at all. So look at this. Is this a parabola graph? Yeah, it could have been the graph of C. Probably not, because I think C actually hits at -2 and -1. Okay, so just familiarize yourself a little bit with domains. So let's just talk about multiplication. So I'm imagining that a long time ago you learned how to multiply fractions, and how were you taught? Like, does anybody remember what they were taught to do? Okay, multiply straight across. So you're going to multiply the numerators, so more maybe terminology, and then multiply the denominators. What could I have done if I had wanted to before I multiplied? Could I have reduced this fraction 2/3 times 1/2 before I multiplied? Okay, what would I have done? The 2's would have canceled because a 2 divided by a 2 is 1. Don't make that a 0, but it's a 1. Are you okay with that? Doesn't matter the order in which I multiply. That sometimes bothers people. Well, I could have done 1 times 2 over 3 times 2. It would have been the same problem, but the fractions look entirely different. But I could have reduced it right away. Do you understand that 2, 6 reduces? Does anybody know why we multiply straight across? Like, how did somebody come up with that algorithm, that recipe? Do you know it all? Okay. What if I asked you to just take 2 times 3? That's a times symbol now. Would you agree if I wanted to draw a picture of that, that 2 times 3? The dimensions here is what? 2. What are the dimensions here? And that's kind of what we did when we completed a square, like we drew pictures. So it is area. So let's see what this is really saying. So I just want to kind of show you, like, somebody did this over and over and came up with this idea that, okay, I see a pattern happening. I'm going to take 2/3 of 1/2. I just restated it differently. 2/3 of a half. Well, I'm going to get a half first. So I've got this rectangle, and I'm going to get a half. So in yellow, I'm going to put this half. That's my half. How much of that do I want? 2/3. So I better get it into thirds. Is my yellow now in thirds? And how many of those do I want? And so what's my answer when you look at that? How many black things do I have there? Out of 6. So that's where 2/6 comes from. So they did it over and over and over, and then thought, there's like a little recipe to this. So by going straight across is just a recipe to that diagram. We could do it over and over and over again, and you would see, we're just multiplying numerators, multiplying denominators. So that's where the recipe came from. Now let's use it. What are you going to do in number 2? Let's think about how we canceled the 2's on this. What could we do with number 2? It's not going to be a lot of fun, but it's going to be needing. Can I cancel the x squareds? That's a good question. Can I cancel the x squareds? What operator are they connected with to the 4x? They're connected with division, but what else? This had all multiplication. What does this have in it? And do they work together? No. And so I need to make everything multiplicative. So what could I do with the numerator of this fraction? Okay. And let's see. Would you agree it would be I think plus 6 and minus 2. Does that give me the positive 4 I need? Okay. Let's factor the denominator. I see it as x plus 4 and x plus 4. So I'll kind of factor these a little bit for you. Can I factor the numerator of 2x plus 8? Is there something I can take out of there? Okay. And you see why I might want to do that? What's going to happen there? Yeah, they're going to cancel. The other thing I don't like is 2 minus x. Who do I always kind of like first with all my other factoring? The constant or the variable? Do you agree the variable? So could I write this as negative x plus 2? Could I do that? But I still don't like that. So I'm going to factor out a negative. Are you okay with what I just did there? Why might I want to do that? Do you see something that's going to cancel with that was kind of disguised? Yeah, who's it going to cancel with? X minus 2 divided by x minus 2 is 1. So we cancel them. Lots of people sometimes think they're 0. No, it's 1. What else? I think we can do x plus 4. So does it matter which one? And what I have remaining is my answer. Would you agree? Leave your answer there. You don't need to multiply it out. You want it in pieces and parts. I can see the pieces and parts. Okay, would you learn about division? How do you divide fractions? Does anybody know? Which one do you take the reciprocal of? It doesn't matter? You're not sure. Keep, flip, change. Okay, so you're saying keep 2/3. Does anybody know why we do that? Okay. Let's look at this for just a minute. And so you can remember it as keep, flip, change. Some of us aren't sure. Does it matter which fraction I flip or change? Could I do it? Would this be the same as if I had changed it this way? Would those have been the same? Are those equal to each other? So it does matter. Why am I flipping the second one and not the first one then? So we know that this doesn't work. So it matters which one I reciprocate, but why the second one? You may not know. So I'm just going to show you because I feel like we just give all this stuff to you and you're just memorize, keep, flip, change, that sort of thing. And some of us don't remember. I don't blame you. So here's what's going on. 2/3 is divided by 1/2. Would you agree that that's the same way of representing that problem? Okay. What kind of things do we like in the denominator? Do we want numbers down there, or is it easier if I have a 1? A 1. Okay, can you tell me what value I could multiply the denominator by that would make a 1? And so my goal is to get a 1 in the bottom. But in math, if I do something to the denominator, what else must I do? Okay. So if I look, this is equal to what? Can I multiply anything by 1 and really not change it? It looks different, but it's really same equality. What's this equal to? So I just made a whole bunch of 1s. And when I do that, did I get the same exact problem that's right here that you told me what to do? So how come it's the second fraction that's being flipped every single time? Because it's the denominator. You reciprocate it to make a 1. That's why it worked. Okay, so it does work, and that's why. And then now it's turned to multiplication, so we already have the algorithm for multiplication. So what would you do on question number 2 if I asked you to simplify that? What would you end up doing? I can't do anything with that. So I'm going to factor these. And what am I going to do, like, mentally? So I feel like at this level, you don't need to write everything down. Write down as much as you need, because I'm going to say, let me see your work. No, I think that right now we're able to do some of this more up here and understand it. So what am I going to change that division to? Okay? And can you envision flipping that fraction and factoring at the same time? So what is x squared plus 11x plus 28 factored? X plus, okay, and are you okay with that? So mentally I'm saying this is going to go to the numerator, and I'm just going to write it factored. So what's going to happen to the numerator? It's going to go where? Yeah, and can you factor it? What parts of 15 make it 2? Okay. So you are going to be factoring, and I know some of us, it takes us some time to think about factoring. You'll get a lot of practice. So what can I reduce here? That's what we're trying to do, is reduce these. Okay, anything else? Anything else? There's your answer. Just leave it there. Okay? You don't have to, I don't want you to multiply it out. Pieces and parts are good. Okay, so here's a complex fraction. I'm going to put a long divide bar there. This complex fraction, why is it complex? Exactly, you have 3 fractions involved. They call it complex. So just like we did up above, if you saw this, what could you do to make this not so complex? Rewrite it, okay? So I could do it a couple ways. I could go 1 over x squared divided by 1 over x. Would you agree with that? Which would then tell me to do what? Oops, excuse me. You want to flip which one? The second one, right? And then what could I do with that? Could I reduce this one? And how would I reduce it? Okay? Now, if I didn't want to do it that way, could I have done this? Made a 1 and made another 1. You see all my 1s? Here's a 1. Here's a 1. So I can do that, and is that the same problem we did? It's just to rewrite it. So it's your choice. Okay, there's certain errors that students make often, and we have to be really careful of this. What do you think the error is on number 1? Like if I'm looking at something, and I just got this off my Algebra 2 test, like half the class is doing this. What do you think they're doing? Yeah, they're forgetting the 2. They're writing it this way. Okay, be very careful. That's the error. So, Xavier, you said there's a 2. Oh, look at, I said 2 and wrote 2. You said there was going to be a 2. Where does that 2 come from? This AB and this AB. Okay, so be really careful of that. What do you think they do in number 2 that's the error? How come I can't do that? What is the power of a square root? Like if I wanted to write it this way, like the last problem, what would I put on the outside? What is the square? What is it? 1/2. So is it the same error that was made here? Just looks different. And what do you think the errors on number 3 that I want to make sure you don't make? What do you think what students most likely do? Yeah, and why can't I do that? Does it make 0 in the denominator? Makes a 1, yeah. Why can't I do that? The addition sign. So if I had 5 plus 2 over 5, would you agree that that would be 7/5? If I try to cancel these two, what does it really tell me my answer is? Is 2 equal to 7/5? No, not equal to. So again, what you do to 1, you've got to do to all 3, okay, not just that 1. Okay, so your homework is online. So let's go ahead and look at that. Let me show you what you're going to be doing. Maybe.